Alright, so welcome back. We're going to go ahead and look at this third example here. So example 3, write sine 3x in terms of sine x. So notice we need to simplify this 3x to just have an expression that only deals with sine of x. And so I also just want you to recall a previous identity that we discussed in the previous section, 7.3, the sum and difference identities section. And so here was one of them. This might come in handy in just a bit. So let's go ahead and get started. I noticed that I have sine of 3x, and so what I'm thinking is I can go ahead and just simplify 3x into 2x plus x. 2x plus x is in fact 3x. And the reason I did this was because now I can use this identity here to kind of simplify or rework some of these things. And so this would simply be, if I treat, let me label these things, if I treat this as my A and I treat this as my B, then all I have to do is just simply substitute A and B into their proper spaces. And so that's what I'm going to go ahead and do. So we're going to have, let's see, sine of A, well that's 2x for us, and then cosine of B, well that's just x, plus, let's see, plus cosine of 2x, and then we have sine of b, which is just x, and so that's nice. And so we're trying to again simplify this 3x and just get down to a single expression involving just sine x. And so what now I'm going to look for is my double angle formulas. And so I notice that I see a double angle right here. I have 2x. But I know that sine of 2x is simply just up here. Sine of 2a is 2 sine a cosine a. So sine of 2x should be 2 sine x cosine x. And so that's what I'm going to go ahead and do. And so I'm going to go ahead and change. I'm going to go ahead and change this little piece right here. And so this is going to equal, let's see, this is going to equal 2 sine x cosine x, right? And that's nice because now I still have that sign there, and now it's in terms of just x, which is kind of what I'm after. I'm going to bring down this cosine of x here, and then I'm going to have plus, and now I'm going to kind of rework this as well. So cosine of 2x. Now I have some options here. I can go ahead and use cosine squared of a minus sine squared of a. That would be fine. I could even use this one, and in fact I think I'm going to choose this one because this one, let me think here for a moment. Yeah, this one right here only has sine squared a involved, which is what I'm trying to get to, right? This one has a cosine in there, so again I'm introducing another cosine squared, and that's something I just don't want to do. Again, you could pick any of those three. I'm just going to happen to pick the second one. This is going to be 1 minus 2 sine squared of x, and then I'm going to bring down this yellow sine x here. So again, I've kind of just used my sum and my sum and difference identities at the very beginning. Now I'm using my double angle identities. So now I'm just going to kind of clean this up. And so if I look here at this first expression, this one right here, we have 2 sine cosine times cosine. This is really just going to turn into 2 sine x cosine squared, since cosine times cosine is just cosine squared. And then plus, now here what I'm going to go ahead and do is distribute, so sine times that 1 there is just going to be sine x. Okay, and then sine right here, sine times 2 sine squared, that's going to be a negative 2 sine cubed. Okay, so we're going to have something like that. And what I'm going to do is, it looks like I'm almost there. If you look at this very carefully, we have our sine x there, we have a sine x there, we have a sine cubed x here. The only problem here is that we have a cosine squared. Now, one thing to get rid of cosine squared is, I want you to think back to one of your identities. We had sine squared of theta plus cosine squared of theta, and that equaled 1. And if we move sine squared, so if I subtract sine squared on both sides, then this cancels out, and I'm left with cosine squared of theta is equal to 1 minus sine squared. And this is nice because now I can write cosine squared in terms of sine squared. And that's exactly what I want to do. So this piece right here, I'm going to go ahead and replace it with this piece here. So this is what it's going to look like. So we're going to have 2, let's see, sine of x. And again, instead of cosine squared, that's now going to get replaced with 1 minus sine squared of x. And then I'm going to go ahead and just bring down everything else. So we have plus sine x minus 2 sine cubed x. And so I'm going to go ahead and just distribute. So let's see, if I distribute 2 times, or 2 sine times 1 is simply just 2 sine x. 2 sine times negative sine is simply negative 2 sine to the 3rd power. And I'm going to bring down this plus sine x here. And I'm going to bring down this minus 2 sine cubed x. Now it's just a matter of combining like terms. So I notice that I have 2 sine x's plus another sine x. That's going to give me 3 sine x. And then I have negative 2 sine cubed minus 2 sine cubed. That's just negative 4 sine cubed of x, and we've done it. We've broken down this sine of 3x, this triple angle, into an expression that involves just a single angle, which is just x. And so this right here would be our answer.